Hello. Let's talk about electron configurations in atoms. Uh, Electrons exist around the nucleus in what we call the electron cloud. And they're not just out there all random and willy-nilly. They have specific kind of assignments to where they belong. The first thing we understood from Niels Bohr is that they have specific energy levels. So there are, depending on how many electrons you have around an atom, there are electrons in the first energy level. And then if you have enough electrons to fill that, then you're going to find electrons in the second energy level. And then if you have electrons to fill that completely, then you're going to find some electrons in the third energy level, and so forth. This concept of electrons kind of, existing in the lower energy levels before they get into higher energy levels is a principle called Aufbau. German word means to build. But what we're going to find out and what we're going to apply is that not only do these electrons belong in main energy levels, and by the way, you notice they're labeled with n's. N equals 1, n equals 2, n equals 3, n equals 4. And we'll find out there's up to 7 main energy levels. 7. But not only do they have these principal energy levels, that's what they're called, principal energy levels, main energy levels. There's also what we call sublevels. Within the first energy level, there is what we call S electrons. They're a kind of electron that behave in a specific way, and they have they've been labeled. And I'm not going to get into the history of why they're labeled with an S, but there's an S type of electron in this first energy level that does a certain thing. In the second energy level, there are also some S types of electrons doing very similar things to the S electrons in the previous energy level. But we find that there's also another kind of electron. Well, it's an electron, but it's going around the atom in a bit of a different way, and that's called a p electron. So in the second energy level, we have what we call S electrons and p electrons, because they're kind of going around the nucleus a little bit differently than the p. I can't talk. Sorry. The p electrons are going around the nucleus a little bit differently than the S electrons. When we get to the third energy level, well, there are some electrons that behave like the previous electrons. They behave like S electrons. They go around the nucleus one way. There are some p electrons. They do their thing, going around the nucleus, behaving a little differently than the S electrons. And then in the third energy level, we have the possibility of what we call d electrons. And they go around the nucleus in a bit of a different way than the other two versions. And so again, we call these sublevels. Now notice, there's a pattern. The first energy level has one sublevel. It's kind of dumb to have a sublevel, and if it's only one level. But again, we want to tell how the kinds of electrons are going. My door keeps blowing open because of the wind. Sorry. The second energy level has 2 sublevels. The third energy level has 3 sublevels. Notice the pattern. So the fourth energy level will have, you got it, 4 sublevels. So there's, in the fourth energy level, we have an S, we have a P, we have a D, and we have the possibility of what we call an F version of electrons. Now, these kinds of electrons, you're limited to only a certain amount in each energy level. So, if you're in energy level 1, you can have S electrons, but there's only 2 possible spots for those kinds of electrons. So that first energy level can only have 2 electrons that do the S kind of orbit. And notice, it doesn't matter if it's in the first energy level, second, third, or fourth energy level. If there are s electrons, there can only be 2 electrons doing the s behavior in each level. Well, when we get to the second energy level, we have p electrons. They're behaving in a different way, and we can only have up to 6 electrons doing that behavior in any orbit. So I can have up to 6p versions of electrons here, or orbits. I can have up to 6p electrons here. I can have up to 6 here, and so forth. So, and that goes the same with the D's and the F's. If there is d electrons, sorry about the bell. If there's d electrons, you can have up to 10 electrons having a d behavior here. You can have up to 10 electrons having a d behavior here. What this does, though, is helps dictate and tell us how many maximum electrons are in any one given energy level. So if we were to total these up, the first energy level has and can only have s kinds of electrons. And that means that this energy level, the first energy level, can only have 2 maximum total electrons. Total. The S and the P's together in the second energy level, well, I can have up to 2 of these versions of electrons, and I can have up to 6 of those. That means I could have a total of 8 overall electrons in that second energy level. Now, they're split, again, between S and P's, but a total of 8. In the third energy level, I can have up to 2 of these versions of electrons, 6 of those versions of electrons, and 10 of those versions of electrons. Well, if I total all that up, that's 18 total possible electrons in the third energy level, which is quite a bit. And then if I keep filling, these orbits and areas with electrons, when I get to the fourth energy level, I can have, 2 plus 6 plus 10 plus 14. That's going to be 32 possible total electrons in the fourth energy level. A lot. Now, we haven't even discussed the 5th, 6th, and 7th energy levels. We will, but we're going to find out, and there's reasons why, that the 5th, 6th, and 7th energy levels look very much like the 4th energy level, meaning the 5th, 6th, and 7th energy levels, they have S, P's, D's, and F's, and they never exceed 32 electrons. Okay? Thanks.
Okay, so sometimes the electrons that are flying around in the electron cloud around the nucleus can be thought of in a weird way like computer files. The whole electron cloud can be thought of as a big file, and there are subfolders or files underneath. Within the electron cloud, we have 7 possible major energy levels. And we always have electrons in the lower energy levels before there's electrons found in the higher energy levels. And that just makes sense, right? So if an atom such as hydrogen or helium only has 1 or 2 electrons, those electrons are going to be found in the first energy level. They're not going to magically just jump up to the 7th energy level. The only way you're going to get electrons up into the 7th energy level is if you have lots and lots and lots of electrons that have already filled up all the previous energy levels. This is a principle called Aufbau. It is a German word. It means to build. So if we look in the first energy level, we can see that there is sub-levels within that energy level. And in the first energy level, that's kind of dumb because the first energy level only has 1 sub-level, so why even have this sub-level? Well, the electrons that are in the first energy level are specific, or have a specific type of orbit. They call this the S sublevel. And inside that S sublevel, there can be up to 2 maximum electrons. So the first energy level has an S sublevel, can hold 2 electrons. Now, once those 2 electrons are placed, if you will, and are found around an atom, if the atom has more than 2 electrons, additional electrons are going to be found in the next energy level, the second energy level. So we go here. But in the second energy level, we notice that it has 2 sublevels, an S and a P. And I'd love to have the S sublevel above the P sublevel, but the computer does this by alphabetical order, so that's not going to happen. Regardless, when we have more electrons in here, they're going to be in the S sublevel and the P sublevel. In the S sublevel, just like in the first energy level, you can have 2 electrons. Well, what this means is that there are electrons in the first energy level that behave a certain way, and there are electrons in the second energy level that also behave in a similar fashion. That's why they're S electrons. Then there's electrons that kind of do stuff a little differently, and we call those the p electrons. They're in the p sublevel. And the p sublevel can have up to 6 electrons in that level. So the p sublevel, the s sublevel, they can have up to a maximum amount in that sublevel. And then, so if we look at this, the first energy level can have 2 electrons. The second energy level can have 2 s's and 6 p's. That's a total of 8 electrons. So we have 2 plus 8. We have 10 total electrons possible now. Now, if an atom has more than 10 electrons, you're going to go to the third energy level. And the third energy level happens to have an S sublevel, a P sublevel, and a D sublevel. Yes, this S sublevel, there are 2 electrons that are possible here that behave very much like the other S sublevels. There is a P sublevel, and that means 6 electrons here, possible, because any P sublevel can hold up to 6 electrons, and those electrons are similar to the P electrons in the previous energy level. And then there's a D sublevel, where these electrons behave differently than the other 2 sublevels, and the D sublevel can hold up to 10 electrons. And what does that mean? Well, that means that the third energy level can hold up to 2 plus 6 plus 10 is 18. So the third energy level can hold 18. By the way, notice a pattern here. Notice a pattern that the first energy level has 1 sublevel. The second energy level has 2 sublevels. The third energy level has 3 sublevels. So if we fill up that third energy level completely, so 2 electrons in the first level, 8 in the second level, 18 in the third level, if we fill up all those and we go to the next energy level, we're getting to pretty big atoms. Well, guess how many sublevels are going to be here looking at this pattern? And you'd be right. There are 4 sublevels. So we have some S electrons, again, holding up to 2 maximum in this sublevel. We have P electrons, again, holding up to 6. We have D electrons, again, holding up to 10. And then we have F electrons, and they can hold up to 14. Then, if we, oh, there goes the bell. Then, if we look to the 5th energy level, if we fill all of these spots, if we fill all these spots and all the previous spots, then the atom can start to put electrons in the 5th energy level. And you'd say, oh, Tapper, there should be 5 sublevels. And you'd be right, there should be. But we don't have that. We only have the 4 energy levels. There is a 5th energy level, 5th sublevel, I'm sorry. It would be the G sublevel. We don't have it listed here because we don't have atoms that exist that are big enough to create this G sublevel. And so if we go to the 6th and the 7th energy level, we'll notice that we never get beyond the F sublevel. Although in theory, there could be more sublevels if bigger atoms were discovered than what we know. But right now, that's not the case.